Hello everyone, today we will continue to look at the content of HCIA Nissan. Our main focus next will be on virtualization. Previously, we have already introduced some basic features of cloud computing, its development history and classifications, among other things. Next, we will mainly look at virtualization. So why are we discussing virtualization first? We mentioned earlier, right? Virtualization is the foundation of cloud computing. So if you want to excel in cloud computing, virtualization is essential. Therefore, in our first session, we will start with virtualization as the primary topic. So, what is the main content of this lesson? What is the main content? The main content of this chapter is mainly about virtualization, the essence of virtualization, including the mainstream technology of virtualization. Let's start. In this lesson, we will mainly focus on the intrinsic value of virtualization technology, including mainstream virtualization technologies, and some basic principles of these mainstream technologies. So next, in the first lesson, we will first look at a virtualization technology. A brief introduction though. First, everyone needs to understand what virtualization is. First of all, virtualization, actually its concept is very broad. We can abstract any form of resource into another form of technology. This is virtualization. It's not necessarily about turning it into a virtual machine to be called virtualization. As long as one resource is transformed into another resource, that is virtualization. It's essentially another logical representation of resources, breaking the fundamental relationship between physical hardware and the operating system, a fundamental relationship. For example, let's take a look at this, PPT. First on the left, we have our traditional IT architecture. Traditional IT architecture. This means you install an operating system on the server, which can be a Windows system, Ubuntu, or Red Hat. All these systems are possible. With these systems, right, after deployment, you can install some software. On them, you can install software. Of course, when installing these software, right, what should you pay attention to? You need to pay attention to the version and compatibility issues. This is a major point to consider when installing and deploying software later on. Here, actually, each operating system must be closely coupled with our specific hardware. Moreover, you can see that our IT resources are completely independent, meaning they are individual servers. So, if I want to run a new program, what do I need? Well, if resources are insufficient, I might need to purchase new hardware, buy new hardware equipment to match the operating system environment we require. In this way, the cost can actually be quite high, and it can also lead to some waste of resources. Because if we are using traditional hardware performance, in this IT architecture, a lot of the hardware performance might not be fully utilized. It cannot be fully utilized. And on the right is our upgraded virtualization architecture. Through virtualization technology, what can we do? Well, we can integrate the whole. For example, below are still physical servers, which is fine, right? Below are physical servers and above the physical servers, we implement virtualization, and through virtualization technology, we achieve resource pooling. Here we have a virtualization layer which acts as an intelligent resource allocation center. The physical hardware resources are abstracted into a shared resource pool. The upper layer operating system? In fact, it has already been separated from the hardware. Previously, our operating system was always installed directly on the hardware, installed on our hard drive. But on the right side, it is completely unrelated now. The operating system and the hardware have been completely isolated. As for the operating system, you can flexibly allocate the resources you need from the resource pool. For example, on a physical server, through virtualization technology, we can run multiple virtual machines simultaneously, and each virtual machine can have a different operating system installed. Moreover, these virtual machines share the hardware resources of our physical machine, such as CPU, memory, hard disk, and network. However, logically, they are isolated from each other and have no relation. They are mutually isolated. This is equivalent to being in one, right? In one. For example, in a server room, right? In a server room. You see, originally, all of our physical servers were all there. They were all placed together, right? All placed together. So here, Overall, actually, after we have done virtualization, the virtual machines inside, they become like individual new servers, which are essentially the same as the original servers, right? They can all be used independently, right? They can also connect with each other, form clusters, and so on. However, they use the same physical resources, including scaling up, scaling down, resizing, and reconfiguring, which is very convenient compared to traditional physical servers. So this is actually one of the basic advantages of virtualization. So why is virtualization so important now? Actually, before cloud computing, virtualization was okay, right? It was somewhat better than the physical architecture, but not by a significant margin. However, with the advent of cloud computing, things changed. If you want to engage in cloud computing, virtualization is essential. Virtualization is the foundation, the underlying layer of cloud computing. Simply put, with virtualization, we can run multiple virtual machines on a single physical server. This allows for efficient utilization of resources. Cloud computing providers can also use virtualization technology to integrate and pool resources from numerous physical servers. Then these resources are provided to different users in the form of services. As users, we don't need to worry about the underlying hardware details. For instance, when you rent a cloud server, you might not even know which brand your cloud server is. You don't know its exact size, how much space it has, or how much CPU and memory it has. What you can see are just some basic details of your virtual machine, and you can only manage this virtual machine. You can obtain the necessary computing and storage resources from the cloud according to your needs. For example, this is particularly evident in some small and medium-sized enterprises. For instance, if you want to start a new project but don't have a lot of computers or computing resources, right? You don't have that many servers. In this situation, traditionally, you would have to buy servers, but at this time, as a small or medium-sized company, right? Your funds are not very sufficient. If you buy all the servers, your budget for other aspects might become quite tight. So at this time, using cloud computing technologies to purchase some cloud servers. Firstly, the cost is relatively low, and the maintenance cost is also low, as you don't need to hire too many people to maintain the servers. At this time, right, relatively speaking, the costs are reduced, and the difficulty of management is also lowered. The adjustment of resources is also very flexible. For these and maintenance companies, it becomes relatively more convenient. Moreover, in terms of computing, virtualization generally involves abstracting the physical resources of our computers to provide one or more operating environments, to achieve simulation, isolation, sharing, and so on of resources. Essentially, virtualization is an abstraction and simulation of hardware resources. In a broad sense, it means abstracting one type of resource into another. But in practice, the virtualization we commonly use is mainly about abstracting our physical servers into virtual machines. This way, it's easier to understand, it will be simpler. By partitioning in space, time sharing, and simulation methods, a single resource can be abstracted into multiple resources, and conversely, multiple resources can be abstracted into one. For example, in terms of spatial partitioning, virtualization can divide the CPU resources of a physical server into multiple virtual CPU cores to be distributed for use by different virtual machines. Even if you only have one CPU, you can still virtualize it into multiple virtual CPUs for our virtual machines to use. Including this, virtual machines can also take turns using resources based on certain time slices. The resources of a physical machine can be utilized efficiently, which is a basic concept of virtualization technology. Of course, virtualization is not only used in cloud computing, you can also directly set up and use virtualization products within your enterprise environment. This includes desktop virtualization, as virtualization applications are quite broad. Cloud computing is currently the main direction. Of course, aside from cloud computing, ordinary virtualization and intermediate virtualization can also be directly used in data centers, and that's perfectly fine. Even if you use it directly, it can significantly reduce resource consumption, including maintenance costs, and it is much more convenient than using physical servers directly. This is a basic concept of our virtualization. Okay, if anyone wants to learn Washington technology or wants to obtain the Washington Question Bank, please send me a private message or leave a comment below the video for technical exchange. Alright, today we will first